Alright, today we'll be doing Problem D, Wooden Toy Festival from Codeforces, round 878. So, in this problem, there are 3 carvers and N people who are each requesting a design. And the designs can range from 1 to 10 to the power 9. Each of the carvers can choose their own pattern X, but they can't really change it. And the time that it takes for a carver just to make a pattern with integer y with pattern x would take x minus y and the absolute value of that. Now, these carvers are skilled and can work on different orders simultaneously. What this means is that one carver can do all the tasks that take less than 5 seconds all at the same time. Like, like if a carver had to complete, let's say, 5 different objects and they all take 8 seconds, he only needs 8 seconds just to complete those um, carvings, wooden toys. And we're trying to find the best maximum waiting time. So we're trying to minimize how long someone has to wait. And we see that the sum of n cannot exceed 2 times 10 to the power 5. And the integers range from 1 to 10 to the power 9. Now this is important because this means we cannot assign a value to each carver and see how it works, because that would take way too much time. So this is not a brute force problem. So what would the solution be? Well, first of all, let's make one key observation. Let's create our number line, okay? Let's say this is our number line. And let's arbitrarily give these carvers a number. A random point on this number line. So let's give this one, I guess, this point. Let's give another carver a point. Well, okay, wait, let's give another carver a point. Let's just say right here, and let's just get another point for a carver about, let's say, right here. So now, why is this important? So as you see, well, let's look at this, okay? So each carver has to take in a certain amount of jobs just to minimize the amount of time. But what we notice is that this carver can take orders from 0 to about halfway between carver 1. Let's just say this is carver 1. Okay, wait. Let's say this is carver 1. This is carver 2. This is carver 3. So carver 1 can take orders from, okay, we need to make this red. But carver 1 can take orders from 0 to exactly halfway between whatever carver 1's number is and what carver 2's number is. Likewise, carver 2 can take values from this intersection point right in between carver 1 and carver 2's patterns, up to in between carver 2's and carver 3's patterns. So about like right here. And carver 3 can just take the rest. Now, what do you notice? We notice that that each of these have a time that, in order for this to work, the minimum time this can take is 2t. So from this point to this point of each carver, it can only be 2t, with t being the minimum time. Because if you think about it, this distance, the distance from x to where the carver 2's position, or each of the carvers, let's say carvers patterns, the maximum time would be the furthest time away, meaning these endpoints. And you start to realize that this problem is not about thinking about what's the best pattern as they show in the test cases, as they explain the test cases, but rather it's about thinking about what's the best time that is feasibly possible for 1 to the largest number. Okay, so now let's solve this. So this is Crystal's solution, as I was having a lot of debugging issues, and Crystal managed to solve it, so kudos to Crystal for that. And let's start. So here, we first create this Boolean um, method just to see if the time works. And we're going to use int mid just to represent time. And the range, as we established, is 2 times mid. As we see here, 2 times mid, which mid could be substituted with t. And start as -1. So start is just to indicate the starting position of the... Well, it's the starting position of whatever range we're looking at. So this would be the starting position right here. And we're going to look from this starting position to this position. And see, okay? And what we're doing is, while we're looping through this, and needed, okay, needed equals 1. So, yeah, so needed represents how many carvers would be needed just to get all that 2t, okay? Now, for each value inside toys, which is the array list that contains all the patterns being requested, if start equals -1, start equals toys.getI. Personally, okay, this works. I would say that that this could have been 0, but this nevertheless works. And start equals -1, start equals toys.getI, which is just toys.get0, so you don't really need to change start. And if toys.getI minus start is greater than the range, start is equal to toys.getI needed plus plus. So what's happening here is the moment that we exit this range, we'll set the new start right here, and we're going to add 1 to how many carvers we need. Okay? And if the number of carvers is less than or equal to 3, that means it's possible for the time to work. Next, for each test case, we set n and initialize a new array list. And we're going to add values to the array list and sort it because we want to get an organized timeline, well, number line as we see here. And then we binary search through every single number from 0 to toys n-1, which is the largest value. And we're going to binary search for each time to see if it works. If it works, we're going to set h to mid. Otherwise, we're going to set l to mid plus 1. The reason why we do that is because we want h to have the value of the solution, you might say, and we add 1 to l here to mid plus, we use mid plus 1 here because we don't want to go in an infinite loop. We can print L because once this resolves, L is going to be equal to H, meaning it's going to be the solution. So we print L, and there we go. That's the solution to Wooden Toy Festival. Hope you guys have a great day.